Welcome to my page. My name is Mumba and I'm a tutor of maths and physics. In today's video, I'll be answering a pure physics question under waves. And the first question reads, what is a wave? A wave is a disturbance that carries energy from one place to another without transferring matter. So to answer the first one, we can say a wave is a disturbance that carries energy from one place to another without transferring matter. Okay, so that's the definition of a wave. A wave is a disturbance that carries energy from one place to another without transferring matter. Okay, so B, water waves are produced with a frequency of 4 Hz by hitting the water surface with a tip of a pen. If the wave travels 20 meters in 10 seconds, calculate the speed of the wave. Okay, so to calculate speed of the wave, we use the formula speed is equals distance over time. You can also use symbols where you say S is equals d over t, where S is speed, d is distance, and t is time. So our correct data in this question, speed is what I'm looking for. I'll put a question mark. Distance I've been given is 20 meters. Time I also have, it is 10 seconds. So I'll substitute these values in the formula where I'll say speed is equals 20 over 10. When you divide the two, I'm going to get 2 meters per second. Okay, so B2, calculate the wavelength. To find wavelength, I'm going to use the formula. Speed is equals frequency times wavelength, where V is equals speed, and then F is frequency. This symbol is known as lambda, is the symbol for wavelength. So I'm looking for wavelength. Frequency I've been given in the question, it is 4 Hz. Then speed, I'm just from calculating, which is 2 meters per second. So I'll substitute these values in this formula. Where there is V, I'll put 2 is equals. Where there is frequency, I'll put 4 times wavelength. So for me to find wavelength, I'm going to divide both sides by 4. This will go. Then wavelength is equals 4 into 2, it is 0 point. So I'll add a 0 here. 4 into 20, it is 5. And the units for wavelength, it is meters. So my wavelength is 0.5 meter. Then I'll come to C. Figure 12.1 shows a wave at a certain instant. The vertical arrows indicate the direction of vibration of some individual particles on the wave. So this is the wave shown here. And the first question says, draw the wave and use arrows to show the direction of the energy. Okay, so I'm going to draw the wave. This is a C. Okay, so this is how the wave looks like. Okay, so to show the direction of the waves, you can see, we can just follow this arrow. We can say, can just do this, then say direction of wave. I'll just put this number here. This is the answer for the direction of the wave. They are moving from the left to the right. Then B, draw the wave and use the arrows to show the direction in which the particle at point X will move. Okay, so when you look at these other parts, the maximum part or the maximum displacement of the wave for Y and Z, the arrows are moving downwards, meaning even at X, the arrows will move downwards. So for 2, This is the answer. Then the last one, draw the wave and use arrows to show the wavelength. So wavelength, by definition, this is the shortest distance a wave repeats itself. So the distance from here to this point where the wave repeats itself, it is known as wavelength. So just say W, which is wavelength. This is for question 3C. Or two successful crests. So wavelength can also be the distance from this part to this top part. Okay, I move on to C. In figure 12.1, which particle is in phase with X? So the other particles which are in phase with X, it is Y or Z. So to answer D, I'll just say Y or Z. Then the last one, explain how the wave in figure 12.1 carry energy. So looking at this wave, it is a transverse wave, and the way a transverse wave, it carries energy perpendicular or at right angle in the direction of the wave. So we can just say E, particles oscillating at right angle in the direction of the wave. Okay, thank you for watching. Please comment on the video, share the video with others. See you next time.